Okay, good afternoon. Okay, I'm Dr. Locke, the course instructor of JIM211 Advanced Calculus. Okay, this is the webex 5 for the JIM211 Advanced Calculus for the academic year 2016 and 2017. So we will continue the webex for chapter 17. Okay, so we have covered the double and triple integrals, chapter 17, sections 17.1 and 17.2. So today we will continue, the rest of the chapter 17, and then until, if possible, until the triple integrals. Okay, but before we proceed to 7.3, I would like to recall 17.1 and 17.2, where we evaluate the double integrals, where the region R is a rectangle. Okay, so let's look at the questions. Tutorial 6, chapter 17, the webex 4. The tutorial 6, we have these questions. Evaluate the double integral over the region R. So here the important is to sketch. The important is to sketch the region R. Why? Because this region R will determine the limits of the integration. You don't have to do anything with the integrand. The integrand remain. Now is the R here will determine what is the limit of integrations, and how to determine, you must sketch the region R. So here the region R is simple, is in the xy plane, and then x from 0 to 1. So this is 0 to 1. Y from 2 to 3. So the enclosed region 2 to 3, 0 to 1. So the region that the enclosed by the line is this. So you have x from 0 to 1 and y from y2 to y3. So the enclosed region is bounded by these 4 lines. So this region R is a rectangle. So if it is rectangle, then in order to determine the limits of integrations, we can choose either dA is written as the dy dx, or it can be dx dy. In this case, if it is rectangle, then you may choose either dy dx or dx dy. See, for example, if I choose, let's say, dy dx. If I choose dy dx, then we will look at y, is from y2 to y3. And x, for x, is from x0 to x1. So when we solve for this first, the y first, then only we solve for x. When you solve this, look at it carefully. When we find the integrations with respect to y, we assume x constant. So the whole thing here, assume it is like a constant. Constant integrate with respect to y, then we will have this, the constant and y. So substitute y2 to y3, and for dx you need to copy, remain. Don't just leave it. You must write here. You found that sometimes where I will always write the x and y, because sometimes I don't want to avoid the confusion. Because if not, then you will confuse. This value is to substitute value x or y. So when I substitute y, then 3 minus 2, I will get this. And then I will solve for it using the technique, the substitution technique, where assume u equals to 1 minus x squared. Okay, so solving this is like in the JIM 101, the calculus. Okay, so at the end you will get your answer is 1 over 3. Okay, the answer is 1 over 3. If you want to write dA as the dx dy, okay, so now, okay, we replace this with dx dy. So now, the limits of integrations now, y from 2 to 3 will be the the limit. And x is from 0 to 1. Okay, now, when you solve for x first, then you need to do the substitution first. Now, right away, and then only solve for y. At the end, you will get the answer is 1 over 3. So you will find that in this case, you can choose either dy dx or dx dy because the limit of integration both are constants. Okay, now we move on to another case where the region is not rectangle. If it is not rectangle, then whether dy dx or dx dy, sometimes only one is suitable. Okay, so okay, there are two types. If your region is not rectangle, okay, so we said that you have the type 1 region when it is dx dy. You can only use the form dx dy. dA replaced with dx dy. The type 2 region is you replace dA with dy dx. Okay, that is this is dy dx. Okay, so the dy dx. Okay, so one is the dy dx, the other one is dx dy. So the difference is, okay, you must write in type 1 when the constant is for x and y is a function. Is a type 2 dx dy when y is a constant and x are the functions. So when you plot, the sketch the region R. Okay, so this is type 1 because you must have constant. Either one must be constant. The constant must be the outer limit. The last one, when you do the integrations, this must be constant. If not, you will not get the answer. Okay, you will not get the answer. So the outer one must be constant. If constant means there are the straight lines. In this case, okay, the outer functions, the y, the x here is x equals to a, and this is x equals to b. If type 2, y, this is y, straight line, y equals to c, and this is y equals to d. The rest, it can be any functions. It's not necessary must be a straight line. If it is straight line, it's a rectangle. A to b, c to d is a rectangle. But now, it is not rectangle, so we must set, okay, either the vertical lines is a straight line or the horizontal lines is a straight line. One is dx dy, dx dy, the other one is dy dx. Okay, this is dx dy because y constant, and this is dy dx. You replace the dA with dy dx. Okay, let's look at the graph. Okay, it means if you have the square, rectangle. Okay, so this is your region R, and then here is any curve. that is Z, the curve. Okay, this is curve. Okay, curve. Okay, the plane, the curve, right? So, but if let's say, okay, now the fix is only A and B, and this can be any functions, okay? And then when you find the double integration, actually you are finding the volume that is bounded above by the Z, and when you project to the XY plane, you have the region R. Okay, the base is the region R. So let's look at these questions. Okay, the final exam 2013-2014, the question 3. This is actually taken from the tutorial question. Okay. So the tutorial 7. Okay, evaluate this double integral. Okay, but now the region R, instead of the straight line, vertical lines, and the horizontal line, now you are enclosed by the curve. So again, the important is to sketch the region R. Okay? To sketch the region R, you must know the functions. So this is 101 again. Okay, this is in how to sketch the x equals to y squared. This is y, y equals to x squared. Okay, please change the question. This is y equals to x squared, x equals to y squared. So for y equals to x squared is easy because we know this is y equals to x squared. Okay, and then x equals to y squared is actually this is the one. Sorry, the curve, So this is x equals to y squared. So the region that is bounded by these two curves, it must be a closed region, bounded region, and the R is actually this is the one. Okay, the R here. So now you need to determine whether you want to treat it as the type 1 or type 2. Okay, if type 1 means you will take x constant straight line. Okay, x from A to B straight line, and then y function. The function curve here this, and the function the other one. So this is type 1. If you want to choose type 2, type 2 dx dy, that means you take y constant. So y must be a horizontal line. Y from the line to line, the horizontal line. Now your x is a function here and here. Okay, so if let's say I would like to try for the type 1. Okay, if I want to try type 1 means I want to take the vertical line. This is x equals to A, and this is x equals to B. I need to determine this. But how to determine the value here? It looks like this is 0, but what is the value for B? So we need to solve simultaneously. Persamaan serentak. The equation 1 and equation 2. Okay, and then I substitute. We can simply just solve substitute 1 into 2. Okay, so we have x equals to y squared, so y equals to the x here replaced with y squared. Okay, so I have y equals to y power of 4. Don't simply like cancel y become 1, y equals to 1, then solve it. No, because we do not know whether if you put, okay, this is wrong, I'll show them. If you put this is divided by y, then you get, oh, this is 1, this is y cubed, and then y equals to 1. Then possible you will lose one factor, because if y equals to 0, you cannot divide with 0. Okay, so don't do like this. Okay, we do the factorization. Okay, y power of 4 minus y equals to 0. We factor y, we have y cubed minus 1 equals to 0. In order to become 0, it is either y equals to 0 or y cubed minus 1 equals to 0. So that we can get this statement is y 0 or y cubed equals to 1. In other words, is y equals to 1. When y 0, you get x equals to, okay, when y 0, x is also 0. When y equals to 1, x equals to 1. So it means the intersection point actually is, this is x0 and this is x1. Okay, the same as the line here, y0, y1. Okay, so now we have the intersection point now, x from 0 to 1. So in order to solve this, let's say I would like to use the type 1. So the 2x plus 3y maintain. dA, I replace with dy dx. When I choose dy dx, x must be constant. That's why x from 0 to 1. Okay, x is from 0 to 1. Okay, now y, the up and down. Okay, so the upper one is the function here, minus the lower is the black color. So the red color is x equals to y square. But we need is actually y, because this is for y. So we must have y. y1 and y2. The upper one, the upper limit. The lower functions, lower limit. The lower one is easier. Black color is y equals to x square. But for this one is x equals to y square. So we try to write in y. So x equals to y square equals to x, y equals to, actually it is plus minus square root of x. But they are actually consist of two parts. One is the positive, the other one is the negative. So it means actually, okay, if y plus means the upper one, this is plus. Okay, the negative is actually, this is the negative one, negative third x, the y. Okay, actually it consists of two parts. So the upper one is the positive third x. So we have the positive third x. So when we solve for this, the double integrations, again, okay, solve for the inner integral first. This remain. Okay, don't forget to write this, but we solve for y first. Assume x constant. So if 2x constant, integrate with respect to y, we have 2x, y. 3y, y, integrate y with respect to dy, the y. So we have 3y squared over 2, and we substitute y, x squared, and y third x. Okay, like as usual. Okay, when we substitute y with third x, we substitute y with third x, okay, minus, we substitute y with x squared, and then simplify. Okay, simplify this. Okay, you should be able to obtain 2x power of 3 over 2 plus 3 over 2x minus 2x cubed minus 3 over 2x power 4 dx. Now, this is easy because with respect to x, as usual, you should be able to obtain the answer is 3 over 4. Okay, so if let's say the same questions, okay, instead of, in this case, it can be dy dx, it also can dx dy. So if let's say the same questions, okay, I would like to write in dx dy. Okay, so it means y must be constant. If y must be constant, that means I need to take the horizontal. The horizontal as the line, the horizontal line. So this is from y0 to y1. So it is y from 0 to y1. And then what is x? X is now, since it is not a rectangle, so x must be a function. So how to take the functions? So when I have this is the line, okay, the function is the x here and the x here. So when we look at here, the upper from lower to upper. So this will be, x1 will be the lower limit, and the right hand side will be the upper limit. Okay, so the lower limit is this. This is x equals to y square. So the lower limit is x equals to y square. The upper limit is this one. The upper limit is y equals to x square. But we need in terms of x. So x is actually x square equals to y. X is plus minus square root of y. So this actually means when you plot the graph, x positive, okay, x positive means this is x plus y. And x negative means this is the one. So that's why we get y equals to x square is the parabola. Okay, but now we want to take only the positive. So it is the positive. So it is positive third y. So when you solve for this question, you should be able to obtain the same answer, 3/4. Okay, but so remember the outer limit must be constant, the limits. And this can be a function, but be careful the functions for x. In this case, if you choose dy dx, x constant, and then y is a function. Okay? Okay. And then now, next example. Okay, sketch the region of integrations and then write an equivalent, the equivalent integral if the order of integration reversed. Hence, evaluate the integral. Okay, this is also question from the tutorial. Okay, let's look at the question 2 here. Okay, so you need to sketch the region R first. So the region R is given. Okay, this is the question. If it is not finding the volume, okay, normally we will not sketch in 3D. We just need to sketch the region R that given here. So when you have dy dx, it means that this is for y, okay, and the outer limit is for x. And now we would like to sketch the graph. Okay, look at here. What we have is x equals to 2, x equals to 0, y equals to 2x, y equals to x squared. This is the region that we have. So when I sketch the region R, x and y equals to x squared is the parabola. Okay, and then y equals to 2x is a straight line that passing through the origin. So the region, and then x is from 0 to 2. Okay, I'm not sure whether the x0 is here, the 2 is the intersection point, or before or after. So in order to confirm it, I find the intersection point. So I have the first equations and the second equations. Okay, and then first equation equals to second equations. I have 2x equals to x squared. And again, don't divide by x, but do the factorization. X squared minus 2x equals to 0. Factor the x, we have x minus 2. So the intersection point 2. There are x equals to 0 and confirm this intersection point is 2, x0 to 2. So the region now is x0 to x2. And then y from y to x and y x square, the curve. So the region R is the shaded here. Okay. Now the question asks us to write an equivalent, that means the same integral, but now the order of integration reverse. So now we need to change. Okay, we need to change to dx dy, reverse the order of integration. But be careful, you cannot simply change. This is x squared to x0 to 2, because for double integrations, the outer limit must be constant. So you need to refer to the region, back to the region, and y constant. Y constant means y are the straight line. So you need to take, what is the y here? Y from 0 to y equals to, so we have only value of x. So just simply find the value of y. So when x equals to 2, y equals to, x equals to 2, y equals to 4. When x equals to 0, y equals to 0. So the intersection point, this is y0, and this is y equals to 4. So now, y from 0 to 4. Okay, so the line will be y0 to y4. Okay, now, we need to determine the x functions. Okay, we will look at it horizontally. If the line here horizontally, so it will enter at this point and then come up with this. So the lower limit will be the left hand side. The upper limit will be the integration will be the right hand side. So what is the function? And function we need to write in x. Okay, so x from lower limit is this, x, the red color, x, but we have y equals to 2x, so change it to x subject, we get y over 2. So it means lower limit is x or equals to y over 2. And the upper limit will be y equals to x squared. So we need to take x. So x is actually plus minus third y. But we choose the positive because it is on the region, the first region, okay, the first quarter region. So we take the positive 1. So it's the third y here. So if you solve, when you solve for these questions, okay, you should be able to obtain until one step. You get y plus 2y 1 over 2 minus 1 over 2 y squared dy, and then further solve it. The answer is 8. Okay, try and see whether can you get the answer 8. Okay, if you solve directly this, the dy dx, you should get the same answer 8. And you solve for the reverse of the integration, but it is equivalent, the same. You get the same answer 8. Okay. Okay, why we want to do the reverse? Because in some case, okay, when you reverse, it's easier to get this answer. So this is the one. Okay, let's look at the next example. Okay, this example is the textbook example. Okay, exercise 17.3, question 6, page 887. Okay, now you would like to evaluate x squared y squared dx dy, where the region omega is given by x from 0 to 1, y from 0 to x. Okay. So for this question again, like just now, okay, you need to sketch the region omega here. Okay, the omega here, the region, x is from 0 to 1. It means, okay, there will be the region you take, this is x0 and x equals to 1. And then y, okay, this means x0, x1. Okay, this y is for y0 to yx. So y0 is the line, the x-axis actually. This is y0. Okay, y equals to x is, okay, pass through the origin, y equals to x. So the region omega is actually, this is the one. Okay, so this is the one. So the questions, okay, if the question is dy dx, okay, if the question is simply dy dx is easier because x constant. So x from 0 to 1. Okay, x from 0 to 1. Y, the upper one is this, the lower one. The lower one is y0. The upper is y equals to x. Then easy. Okay, so you just need to solve 0, 1, 0x, x squared, y squared, dy dx. And when you solve, you should be able to get the answer is 1 over 18. Okay, this is easier. But the question now, instead of dy dx, the question would like you to write in dx dy. So in order to write in dx dy, look at the omega, the region. X should, dx dy. So y should be constant. When y constant means the horizontal line. So we need to take, this is y0 and the other y. What is the value of y here? It's the intersection point when x1, y is 1 because of this point. Okay, so y from 0 to 1. What is x? So y from 0 to 1. The region now, we look at it horizontally because it's a type 2. Okay, the enter point will be the lower limit. The enter point is y equals to x. That means we need to write x equals to y, the same. Okay, the next one will be this. What is the line here? This is x equals to y, and this is actually x equals to 1. Okay, so you need to solve 0 to 1, y to 1, x squared, y squared, dx dy. Okay, x squared, y squared, dx dy. So at the end, you will get the same answer with this one is also 1 over 18. Okay, you should try to do more exercises. Okay, you try to solve for this one. And then when you reverse the order of integrations, you should be able to obtain the same answer, 1 over 18. Okay. Okay, let's proceed to the next one. This is okay. Should be one negative only. Okay, one negative only. Okay. So it's only one negative, Please cancel the other negative. Okay. So this is just the symmetry, in double integrations. Okay. It just said that if the region omega is symmetric about the y-axis, okay, so it's a symmetry about the y-axis. If f is odd, then the double integration for the function is 0. If f is even, then 2 times one of the region. Okay, so maybe I would just quickly explain about this. Okay, so if let's say the functions f. Okay, the function f is symmetric about y-axis. Okay, so that means, okay, is a symmetry about the y-axis here. So if f is odd, okay, if f is odd, that means you're going to have the symmetry is the negative like this. Okay, if a symmetry about y, when f is even, that means, okay, the symmetry is like this. Okay, f is odd, f is even. So if let's say I would like to find the integration for the functions, okay, let's say, okay, from this is a region omega, the omega here, and the omega here is, let's say, from here to here. So it's like in the 101, if f is symmetry and it is odd, okay, when you have the region here, okay, if you didn't put the modulus, then it will be negative. So it's a negative, this area R plus the area R. So that's why when you combine, you will get 0. But if it is even, okay, the region here plus the region here is 2R. So 2 times the region. This is the meaning, okay, for the symmetry. Because sometimes, if you notice that the graph is symmetric, then you just need to find the other half, then times 2. If it is odd, then you can simply say the answer is 0. But this, you must confirm, you know the graph. Okay, you know the graph and you know it is symmetry, you know it's odd, you know it's even. Okay, if not, then don't simply make this conclusion. Okay. Okay. Now, we move on to 17.4. Okay, the double integrations that we discussed just now, all is involved the Cartesian coordinates. That means x and y, the region R, x and y. Now, the x and y, the coordinates, we can represent the line with the polar coordinates. This you learn also in JIM 101. Okay, the relationship between the same point, the same coordinate points, but if you want to represent using the polar coordinates r theta, the relationship is x equals to r cos theta, y equals to r sin theta, and the dy dx or ds dy, or in general dA, replace with r dr d theta. Okay, this is actually how to get this. This is a Jacobian matrix. Okay, if you learn the jim211, you can prove. Okay, the dA equals to r dr d theta. We have the extra r here. Okay, in jim211, you will learn how to prove this using the Jacobian. Okay, so let's look at the question. The final exam 2014-2015 question 2A. Okay, this is also I copy it and then to your tutorial questions. Okay, tutorial 7, the question 3. Okay, given the integral, and this integral is in Cartesian coordinate. Now we would like to change the Cartesian integral into an equivalent polar integral, hence evaluate the integral. So the way to change to the polar coordinates, first, look at the integrand. The integrand can simply use the formula to change. Okay, you can simply use the formula to change to r and theta. Okay, because we know x equals to r cos theta, y equals to r sin theta. So it's very easy to prove that x squared plus y squared is equals to r squared. Okay, because when you have x squared, r squared cos squared theta, plus y squared is r squared sin squared theta. When you factorize r squared, cos squared theta plus sin squared theta, the value is 1. So that's why you get r squared. So this x squared plus y squared become r squared. Okay, dy dx, we can change to r dr d theta or r d theta dr. It can be in any. Okay, so we need to change to either r dr d theta or r d theta dr. But how to determine which one is suitable? Okay, and then which one, what is the limit? You need to sketch the region R. Whatever, you need to sketch the region R. So what does it give us? It gives us that this is for x equals to 1, x equals to 0, y, this is for y equals to 1 minus x squared and then the square root, and the other one is y equals to 0. Now, come up with the question, what is this graph? Looks like we do not know, they have the square root. So the easier way is, okay, I will try to look at if without the square root, what does it? Okay, so if I want to eliminate the square root, that means I need to square. Okay, I need to square the right and the left. Then I will get y squared equals to 1 minus x squared. And when I put the minus x squared over here, x squared plus y squared equals to 1. This is the formula for the circle with the radius 1. Okay, so it means that if I want to sketch for x squared plus y squared equals to 1, this is actually a circle with the radius 1. But this is actually x squared plus y squared equals to 1. If I divide into two parts, okay, if this x squared plus y squared, I put y as the subject. Actually, y squared, we have plus and minus square root of 1 minus x squared, where it divides into two parts. One is the y positive, and the other one is y negative. So if you want to write in y, it means y positive means the upper part. So this equation is y plus, and the lower part is y negative. Okay, so combine all together, x squared plus y squared equals to 1. But if you want to divide into two parts, actually that one is y positive and the other one is y negative. So the graph for this is actually the upper part. Okay, so that means, okay, the regions are here. Okay, the region R here is the hemisphere, upper part, with the radius is 1. So this is y equals to 1 minus x squared x here. So this is only the line here. Okay. Then y0 is the line. Y0 is the horizontal line. This is y0. Okay. Y0. The hemisphere y third 1 minus x squared. And what is your x? X is from 0, x0 to x1. So the region that is bounded by this line and this line and the curve is actually the quarter of the circle. This is the region R. Okay, so now we want to change to the equivalent polar coordinates. So I put r dr d theta. Remember, theta here is a constant. Theta is the angle. Okay, so for r is from the origin r to the radius 0 to 1. Theta is the angle. This is theta 0. So your theta is moving until theta pi over 2. So this is 0 pi over 2. So if the region is in circle, it would be easier to change to polar coordinates because you will find that it's very easy to get the answer is pi over 8. Okay. So because it's a very simple. Don't forget, there is r squared and there is r. So when you solve for this, it's actually r cubed, dr d theta. So you need to solve for this r power 4 divided by 4, and then so on, and you get the answer pi over 8. Okay, so you get the answer pi over 8. Okay, so this is changed to the polar coordinates, and you found that it's quite easy to get the answer if your region is in the circle form. Okay, if your region is the circle, right? Okay, so you change, if region is the circle form, it's easier to change to polar coordinates. Okay, but everything you need to change to r and theta. So here x squared plus y squared, you should write in the r, right, or theta, right? Okay, now we proceed to the next sessions. Further application is just a formula. Once you know how to evaluate the double integral, then if lambda, you just use the formula and then you will get the answer. This I'm not going to discuss detail because it's the application. Okay, you know how to find the integration, then you just use the formula, get the answer. Okay, the example, please refer to the textbook. Okay, you can use the double integral to find the mass, center of mass, centroids, moment of inertia, the radius of gyration, the parallel axis theorem, to find actually this is the moment, moment, and then line parallel, the parallel axis theorem. Okay, so this is, I'm not going to show this. Okay, now I would like to, before I move on to the triple integral, there is one question in the tutorial, okay, that I would like to discuss here. Okay, I'll discuss very fast. Okay, use the double integral to find the area of a region enclosed by the parabola y equals to x squared and the line y equals to x plus 2. So now we want to find the area, but using double integral. Remember, the formula to find the region, the area is double integral. The formula is 1 dA, and this is the region R. Okay, so it's 1. So your dA can be dy dx, can be dx dy. It depends on your region R. So you need to sketch the region R. Your region is enclosed by the parabola y equals to x squared and the line y equals to x plus 2. That means there is a line. You must know how to sketch the line. So it is enclosed by this region. Okay, so you need to find the intersection point. Okay, you need to find the intersection point. So you need to determine what is the value here and value here. Okay, so if you do it carefully, okay, you will get the value here is x negative 1 and this is x equals to 2. So, okay, the x, if I choose the type 1, x negative 1 to x 2. So your y will be, okay, the lower limit of integration and the upper one is this. So, okay, the area is equals to 1. I would like to use dy dx, the type 1. X from negative 1 to 2. Y is, this is a y equals to x plus 2. And the lower one is the curve, y equals to x squared. So just simply solve this, okay, and get the answer. Okay, okay. So, and then now I would like to move on to the triple integral. Triple integrations, we still have some time. Okay, so the triple integral over a box. Okay, the volume as a triple integral. Okay, so let's direct go to this question. Okay, this is the region. Now, just now, the double integral region R is in 2D. For triple integral, this is not the 2D anymore, is in 3D. We call it the solid T. You are now integrate with respect to the solid T. And this solid, if all are constant, then it's very easy. Okay, so now, okay, this is the question final exam 2015 and 16, question 5. Okay, so let's get this question. The question, okay, let me copy the question first. Now you have a triple integral x, y, z, dv. Okay, your t is x from 1 to 3, y negative 1 to 2, and z from 0 to 2. Okay, so according to the formula here, there's nothing here. Okay, so if all are constant, then would be very easy. Okay, so now this t is a solid bongkah. That means it's in 3D. If you plot this, it's actually x and y and z. You will notice that it's a cuboid. Okay, x from 1 to 3. Y from negative 1 to 2, and then z from 0 to 2. The height is 2. So you are going to get the cuboid. Okay, the cuboid, because it's all constant. If all constant, then there is no problem. Okay, you may write dv in many combinations: dx, dy, dz, dx, dz, dy, dy, dx, dz, dz, dx, dy. You have many combinations, so you may choose any because this is constant. Constant, you will sure to get the answer. So if let's say, okay, I would like to use, let's say, dx, dy, dz, then z is the outer limit. Z from 0 to 2, y negative 1 to 2, x 1 to 3. So when you solve, we say it's a solve iteratively. You solve for the dx first. When you get the answer, you solve for dy, and then get the answer, then you solve for the dz. Okay, so okay, you should be able to obtain the answer is 12. Okay, let you try and see whether can you get the answer 12. If you don't get, then we may discuss in the forum, in e-learning portal. Okay. Okay, then there is another, okay, deduction to repeated integrals. Remember, okay, the cuboid t is cuboid is all constant. But how about if your solid in 3D is not all constant? It's not the cuboid. It can be in any shape. It can be in cylinder. It can be in any form. Okay, so remember the keyword is the important point is when it is not a constant, you must make sure the last one, when you do the integration, the outer limit must be constant. The inside functions is okay. The outer one must be constant. Okay? Okay? So this must be constant. So let's, if you look at this question, you see, the two x, y, z, the function in x, y, z, z from here to here. But the outer limit, when finally, the last one when you solve is from 0 to 1. Okay, so this is the last example. I would like to show it very quickly. Okay, so for this question, okay, so it's also from the tutorials. Okay, So when you solve it, 0 to 1, sometimes to make it very clear, I will write what is this is for. So this is for y, x squared, yx. This is for z. This is for z. And 2x, yz, dz, dy, dx. So I will solve for z first. Assume x and y constant. Okay, assume x and y constant. So 2x, y, z. I integrate with respect to z, assume constant. So I will get 2x, y, z squared over 2. And 2 simplify, I get x, y, z squared. And I substitute z with x minus y and zx plus y. Okay, so remain. Okay, xy constant, because like a constant, because I substitute only for z. So xy, I will just substitute z minus substitute another value z here. So this is for zx plus y. This is for zx minus y. When I simplified it, okay, when you simplify, you will notice that this part you get 4xy. Okay, then 4xy times xy. Okay, 4xy times xy. So we obtain 4x squared y squared dy dx. Okay, so then solve for y. So 4x squared y squared, we integrate, we get y cubed over 3. And substitute for y(x squared, yx, and then remain the last one. You should be able to obtain this part. You will get 4 over 3 x power of 5 minus x power of 8. And finally, when you solve it, you get 2 over 27. Okay, so when you solve for this question, you will notice that there are, remember the index. When you have x power of a times x power of b, the index here we plus. But if you have x power of a, power of b, that means a times b. Okay, you must remember this index. Okay, try and do it and then get the answer. See whether can you get the answer. Okay, if not, then we may discuss why. And you can email to me where is the workings, where's wrong. Okay, I can mark and then point out for you. Okay, so one thing, don't forget about assignment 2. Okay, submit on time. And then if you log into the portal, you will notice that I have uploaded the grade for the test, PB test. If you happen to come to Penang, USM, you can make appointment. You can come and collect your test, PB, or if you want to collect for your friends also can. Okay, so I think that's all for today. Okay, when I look at here, there is none of y'all is in the webex. I mean the login. I mean in the line. Okay, if there is no questions, then I'll stop here. Okay, I'll meet y'all again in the last webex, webex 6. Okay, so thank you very much.